In this short training video, we will demonstrate how to set up a combination of tools to figure out a simple box dimensioning and box void fill application. Box void fill just means we're going to find out how much empty space is left in this container. Now, if you're following along, we assume you've already taken the time to acquire a good clean image using the scan page settings in your sensor. Now, we offer a full suite of sensors with different ranges, different fields of view, and resolutions depending on your needs. So your image acquisition settings are going to be different because they'll be tailored to your application. Now, we also assume that you're familiar with the Gocator software, so we'll be moving pretty quickly in Gocator Classic version 6.1. If this is your first time using the Gocator software, I recommend you sign up for one of our Introduction to Gocator GUI courses on lmi3d.com before jumping into this video. In this demonstration, we'll show how to solve two applications at once: box dimensioning and calculating how much empty space you have left in your box. We'll also convert the final measurements to centimeters for a more usable volume measurement. We can figure out the application with a combination of 4 different measurement tools: surface pattern matching, surface bounding box advanced, surface volume tool, and finally the script tool. Now, we've recorded 5 images of boxes. I'll just flip through them real quick. That's our first one. Our second one is a little out of alignment. Our third one has a few items in it. Frame number 4 is almost packed to the top there. And frame number 5 is completely overflowing with stuff. So what we're going to do is, now that I've shown you how the tools stack, we'll look at the end. We're going to wipe all the tools and we'll walk through them together. We've removed all the tools and we'll walk through how to add all of them, and we'll go through all the different steps. So the first one is adding the surface pattern matching tool. Now, with the surface pattern matching tool, we want to make sure that we are adding it to our ideal part. Now, in this case, we'll start with frame number 1, just because it's an empty box. We don't need the pattern of anything inside of it, and also it's fairly aligned with our X and Y axes. So I'm going to first do a top-down view just to make this easier, and also I'm going to go to grayscale just because the region of interest box is yellow and it's a little hard to see over our height map. So once I've changed my region of interest, I'm going to click on Show Details just so we're able to see the pattern that is being created. I'm going to go to the Operation menu drop down, click Create, and then I should be able to see my pattern. Now, what I can do is I'll turn off my region and I'll flip through frame number 2, 3, 4, and 5. I'm pretty happy with that pattern that's been created, and you can see how it moves and rotates with our empty boxes. We're going to use that to anchor other tools on top of it. Now, to be able to anchor, we also need to be able to have those measurements as an output. So I'm going to turn on my X, turn on my Y, and turn on my Z angle. Next, we'll add the surface bounding box advanced tool so we can get the length, height, and width and calculate an empty box volume. And then later, when we add the surface volume tool, we can subtract in real time what that volume is going to be and get our void space. So let's add our surface bounding box advanced. And the reason why we're using surface bounding box advanced instead of just the bounding box tool is because we'll use the height from 0, and I'll show you that in a quick second. So same sort of thing, we want to stay with our golden part. We'll just stay with frame number 1. Again, it's nice and lined, it's an empty box. And I need to use turn on region. I'm also going to make sure I turn on my rotation so that the bounding box rotates the way I want it to. I'm still in my top-down view. Let's get the interior volume, because if we just snap that box around, or our region of interest around the whole box, we're going to get the volume of the entire box, which is not entirely accurate. We just want the inside of that box. So I'm going to take a little bit of time here. And then now I'm also going to go to the Z view. I'm going to make sure I have that box exactly where I want it. You can see that the teal box right now is being drawn a little bit low. That is not where I want it. I'm going to change that a little bit. Just so I can get the inner volume of my cardboard box. I'm going to go back here. So I am pretty happy with that. I've decided on the lowest part of that box. I'm just going to split the difference between where those flaps come up. so I can get kind of an average value there of what falls in the cracks there versus what is being up on top. So now that I'm fairly happy with the size of that volume, I'm going to make sure I anchor it so that it rotates. So I'll click on the anchoring tab. For my X point, I'll choose that pattern matching tool. My Y point, I'll choose the pattern matching tool. There is no Z point because the surface pattern matching tool makes a 2D outline pattern. So there is no Z point there. And finally, for the Z angle though, I will choose the surface pattern matching tool. Now what should happen is I'll go through my frame number 2. It should rotate nicely. Frame 3, frame 4, frame 5, I'm pretty happy with that. Now the final part to make sure that I have a nice, repeatable, reliable measurement is I'm going to turn on all of my measurements here. And in this case, so what I brought up before was height from 0. What we're going to use height from 0 instead of the height measurement because we want to make sure that we get the bottom of the cardboard box even though it's not going to be visually inspected. Where this comes into play is frame number 5, where our box, we've crammed it full, we cannot visually inspect the bottom of the box, but we need to get an accurate volume. In this case, we can get that volume from the 0 axis. Now to get this, you have to make sure that you've aligned your sensor so that your 0 axis is sitting where the bottom of the box is, otherwise this won't work. So as I was saying before, how do we make sure we get a reliable, repeatable measurement? Let's just walk through those frames and make sure that the region of interest that I've drawn is going to give me some good, reliable measurements. So let's use height from 0 since we've been talking about it. Right now I'm looking at frame number 5, it's giving me 199 millimeters. Frame 4 is 199, frame 3, 199, 2, 198, and 198. I'm pretty happy with that. It doesn't get much more reliable than that. I'm just going to walk through and eyeball the other measurements, and those look pretty standard through each different frame. The next step is we will add the surface volume tool. This one is going to measure in real time the volume of what's inside. So just add the surface volume tool, and same thing, we'll go back to frame 1. We want to anchor this down. We'll use our golden part. So I'm just going to put it inside, and this is where, again, I'm just using the top-down view. I want to just get the inside volume here. And I'm also going to leave it a little bit tall because I know that on frame number 5, we have jammed this thing right full, and we want to be able to measure and capture that. There we go. So our surface volume is, I'm keeping it a little generous just because we're going a little bit fast today. In real time, if this were a true application, I'd probably spend a little more time just adjusting my points. But for today's purposes, we're going to move a little bit quicker. So I'm happy with this, and now I'm going to anchor it down. I'm going to use the surface pattern matching as my X point, surface pattern matching as my Y point. I'll use the bounding box advance as my Z point, again, because surface pattern matching is squished down on 2D. It does not have a Z point, but for the Z angle, I'll use my surface pattern matching as well. So now when I go through my different frames, I'll look at frame number 2. That you can see I've gone a little too close to the edges. There we go. So I've got 0 on an empty box, 0 on an empty box. And now we should be able to start calculating when we find items inside the box. The last thing I'm going to do now is I'm going to convert this from millimeters to centimeters, just because if we get roughly a couple million millimeters cubed, it's not going to do us a whole lot of good. So I'm going to move the decimal places by 3 just because we're dealing with millimeters cubed. And now we can, we will see. What do we got? So we got 28,000 centimeters, 14, 5,000, empty, and empty. So now it's showing up as green and red. If you haven't used Gocator before, that just means we haven't set our pass-fail yet. So any value is going to show as unset, or it's not happy with just because we haven't set a pass-fail yet. Finally, we'll add the script tool. Now I'm going to cheat a little bit because we have a script already prepared. The only thing that you'll have to make sure is you have the correct output IDs. So with this script tool, I'll add it, and this can provide a nice template for you. I'm going to just grab that here. And what we can do is we will walk through this script once I've applied it together, and we can take a look and see exactly what's going on. So with our script, we have three parts to our script. First, we're going to calculate the volume of what we're going to call the volume box, volume in centimeters. All we're doing is we're multiplying the length by the width by the height from 0. Remember, we're not doing height, but height from 0. And also we're converting it, we're scaling it down by 1,000 so it matches the scaling we did back in the surface volume box. The second part of the script is calculating the void fill volume, or the empty space left in the box. We're just taking that length times width times height, what we call the volume box volume, and we are subtracting the surface volume measurement tool, which is ID 105, I believe. We'll check that in a second. And the last part is we're just making an output so you can see what's going on. The other thing I'm going to do, just so that for demonstration purposes, is we're going to add a couple extra outputs just so that you are able to see all of those subtractions happening in real time. So you can see it's invalid right now. I'm going to set those outputs. One is going to be the volume box volume. The other one is going to be the measurement value. Control S to save, escape out of there. So let's take a look at what's going on here. We have our empty box. Now what I'm seeing is that our volume, which is 0, and our bounding box advanced is giving me a negative number, which leads me to believe that my IDs are not set correctly. So I'm just going to double check that my width, my length, and my height from 0 are the correct output IDs. To look at that, we go to the output page. I'm going to scroll down, and I'm going to look at my surface bounding box advanced. Width is value 5, the length is value 7, and the height from 0 is value 8. So I'm looking at 5, 7, 8, and I believe that the script that I created is not using those correct values. Remember, 5, 7, 8. Let's go back to our script tool, and sure enough, that is not multiplying the correct value. So we want ID 5, ID 7, ID 8. Control S to save, and now that's going to give me a more accurate, so that's actually multiplying the length, width, height from 0 the way we want it to. So now when we look at, we have our outputs. I'm going to rename these outputs just for my own mental organization. So let's call this first output, we have it right there, we call it void fill volume. We'll call it void volume. That output number 1, or this other one here, we'll label this width times length times height from 0. And this last one here, I believe I've named it the inside volume. And this is just watching the surface volume tool at work in real time. So as we walk through the script now, frame number 1, empty box, our void volume and our calculated volume should match, and that's correct. That second box there, same thing, there's nothing in it. Our inside volume should be 0, there's nothing in it, and our calculated volume should be exactly the same. We're happy with that. Now as we start to walk through this, where now we have that third frame, where we have just a few items in here. The inside volume is about 5,000 centimeters cubed, and we're seeing that starting to be subtracted from the length, width, and height from 0, and our void volume is starting to decrease even more. And on the overflow, now we can see that the inside volume is beyond what's in the box. We're getting a negative number, and that signals that we have way too much stuff in the box. Now there are ways to, and they're very easy, to set an alert so that if you have something overflowing inside your box, you can set an alert, you get an alarm, or there's other ways where you can convert your measurements, like we just did, millimeters to centimeters. You can change it to imperial, you can change it to whatever you like. We don't have time for that today, but it is very easy and straightforward. If you have an application like this, please reach out to us. You can find the sales contact form on the contact tab on lmi3d.com.